All right, let's try some practice problems with equilibrium. So specifically looking at here, we're going to do static equilibrium because that just means it's stationary. Equilibrium, again, remembers the acceleration is zero. So this tells me the acceleration is zero, this tells me the velocity is zero. So what we want to do is we want to say when I add up all the forces, there is no net force, there is no acceleration, so the sum of my forces needs to be zero. So go ahead, see if you can calculate the tension holding up that 5 kilogram weight as a practice. Is that what you got? 49 newtons for the tension? If so, good job. Next, we're going to do example. This one's a little different. Now I have multiple objects. And so whenever we do multiple masses, we need to make sure they have the same acceleration. In this case, they're both in equilibrium, so they do have a common acceleration. And there's always going to be a force that's the same for both of them. That's the force that connects them. And so they are connected by this string. So tension 2 is going to be in both free body diagrams. So let's set that up. So our 3 kilogram weight is being pulled down by tension 2. It's being pulled down by gravity. We'll just call this M1. And it's being pulled up by tension 1. So when I generate my equation over here, I have tension 1 minus tension 2 minus M2G. Oops, sorry, M1G equals 0. All right, so how many unknowns do I have here? I have 2. So it means I need another equation. So that's where we're going to use our other mass. So here I have M2G and tension 2. Now you'll notice these two tensions are opposite and equal. This is a third law pair here. All right, so I'll generate this equation here. So I have T2 minus M2G equals 0. And so here I can solve for T2. So T2 is going to equal M2, which was our 6 kilograms, times 9.8. So T2 comes out to be 58.8 newtons. Well, now that I know T2, I can bring that over here because whenever we have multiple masses, there's that common force. I can say T2 is going to be 58, find T1. So I have 3 times 9.8 plus that 58.8. And so T1, of course, being larger because it is holding up 9 kilograms, not just the 3, it's holding up the 3, and then the 3 is holding up the 6, so the T1 is holding up both. And we should get 88.2 newtons for that one. All right. So next, we're going to start to kind of make these a little more complicated. Multiple masses. We're going to add some angles in there. So let's go on to that.